I'm going to give you an astounding result.
The answer to this is, Brady?
Well, I would say it would tend towards infinity.
Yeah, that makes sense, doesn't it?
The answer to this sum is, remarkably, minus a 12th.
This result is used in many areas of physics.
This is a very well-known string theory textbook by Joe Polchinski. As you can see, sort of quite early on, page 22, we have this statement here, which clearly, that's obvious, right? So what number are we going to attach to this infinite sum? Do we stop at an odd or an even point? Well, we don't know. So we take the average of the two. So the answer is a half. And then I'm going to add to it itself, but I'm going to shift it along a little bit. So that's plus 1, minus 2, plus 3, minus 4, which implies that S equals minus a 12. So now do you believe me? That's amazing.
People always come to me and ask me what string theory actually is. And there are two possible answers. There is the formal answer that string theory is a theoretical framework in which point-like particles from particle physics are replaced by one-dimensional objects called strings. But the truth is that this doesn't capture at all the essence of the subject. There is one equation, one single equation, that explains everything in string theory from the beginning to the end. And I really can't describe in words the pleasure I feel to have now next to me the emeritus professor, the genius, who solved this equation. I wish to welcome as warmly as possible the creator of string theory.
Marius, for me, is always big pleasure to talk to audience, your audience. Although I'm not sure they can understand my genius idea. Okay, so back to your question. What we want to do in string theory is to have a short equation, very short, inch long equation, to explain what is going on in nature. Okay, so we deal with natural numbers, for example, 1, 2, 3, and so on, and the question which arises in string theory, because we care about nature, is to say how much 1 plus 2 plus 3 plus so on it really is. Some professors claim they prove it equals minus 1 over 12,
but that's wrong, that's wrong.
Yeah, it is, because they use some erroneous calculation when they do that. Actually, I have the answer, as you said to your audience, and the answer is they equal 0. This sum equals 0. Yeah.
So, Professor, would you enjoy to show us the solution to this problem?
Yeah, well, unfortunately, I think I already think of a level with nobody in the audience can perceive. So I'm not sure I connect with the audience very well, but maybe you could try to solve to them.
Indeed, hardly I can think that a large audience would understand the subtleties in such an intricate proof that you would expose, but I can try. So basically, we are interested in computing the sum S equals to 1 plus 2 plus 3 plus so on. And, Professor?
Oh, yeah, so, yeah, what you're saying, yeah. So.
But there are two main ideas. The first idea is to produce a copy of S and to write it beneath it. But not exactly beneath it, to push it to the right a bit. And you obtain again the sum S equal to 1 plus 2 plus 3 plus so on. And you add these two. So what you obtain now is that 2S equals to the sum of odd numbers. 1 plus 3 plus 5 plus so on. So this was known before 50 years ago. But this man here came with the brilliant idea to represent the even number.
Sorry, if I can call it genius, if you excuse me.
Of course, Professor.
Yeah. So, yeah.
And he came up with this brilliant idea to multiply s by 2 and obtain 2s again equals to 2 plus 4 plus so on. And then what he did was purely magic. He added these two to obtain again the sum s. So he would obtain 4s equals s now. So this, after some calculation,
of course, some intricate calculation, yeah. So.
Maybe pages of writing, implies that 3s equals 0, which further implies that s equals 0 and not minus 1 over 12, as some narrow-minded people would believe.
Yeah, so it's very interesting because it's very counterintuitive. Why would equal minus 1 over 12?
When 0 is such a natural thing to
it's clear it's 0. I mean, everybody saw saying when you add some positive natural numbers, of course you get 0 in the end, yeah. So, I mean, genius here. But what your public might not know is that this equation actually summarizes all the work which was done in string theory. And can I further add a very short thing, that when we reach this equation, because it was, you know, string theory, as maybe your audience doesn't know, string theory is a theory, a new theory that is not proved very well. So when we reach this point where we see, well, actually the sum 1 plus 2 plus 3 equals 0, we are at the right spot, right? We are on the right track to go further and develop this theory into bigger thus based on this basic game. So it's very encouraging for the scientists like us here. Even for you.
Indeed.